Sketch the following quadratics, labeling any key points. First of all, this quadratic here is given in root form or factorized form. So we'll sketch our axes. And with our axes plotted, we need to have a root at 2 and -3. So approximately here and here. It's a positive quadratic, so it's going to have our classic U shape of a quadratic. It's going to go something like that. Labeling the points 2, -3, and labeling the y-intercept as well. When x is 0, we get -2 times 3, so that's going to be at -6. The second quadratic is also in root form, because we have the two brackets being multiplied. The roots this time are at -1 and -6, so something like that. And it is a negative quadratic, so it's going to have that classic N shape here. So it's going to go up through the -6 and then down through the -1. Labeling those points, -6, -1, and our y-intercept when x is 0. 1 times 6 is 6, times -2 is -12. This third quadratic, this time we are in completed square form or vertex form. So the vertex is going to be at 2, -5. So 2, -5 is going to be about there. It is a positive quadratic. Let's think about where the y-intercept is first here. Is it going to be above or below the axis? When x is 0, we get -2 squared, which is 4, -5 is -1. So it's going to go below the axis. So our quadratic is going to come down of its vertex and then back up again. We said that point there was -1, and the coordinates of the vertex were 2, -5. Moving on to these three. The fourth one here, it's in vertex form again. So we have our vertex is at -1, -4. So -1, -4. This time it is a negative quadratic, so it's going like this. So this time we can actually draw it first because it doesn't matter if because we know the y-intercept is going to be down here somewhere. Extend that y-axis a little bit down here. And to find that y-intercept, it's when x is equal to 0, so we get 1 squared. And minus that, so it's -1 and -4, so that's going to be at -5. And that point was at -1, -4. For this one, we first of all need to factorize or complete the square. Can we factorize it? Let's think. Two numbers that multiply to make -15 would be -5 and 3. Does that work to give us the -2? Yes, it does. Because -5 plus 3 gives us the -2. So factorized, it would look like this. Let's sketch this then. It is factorized. So we've got a root at 5, a root at -3, and it's a positive quadratic, so it's going to come down and then go up, labeling our points, the 5 and the -3. The y-intercept we can read from here is going to be -15, and that's enough. Alternatively with this one, we could have completed the square. We would have got x -1 squared, and then take away 1 to get rid of that 1 squared, take away 15, so it's going to be -16. That's telling us the coordinates of the vertex here. The vertex has coordinates 1, -16, which does match up with what we have drawn here, but maybe we would have chosen to have done it with that point instead. For this one, let's think, can we factorize it? Two numbers that multiply to make -16 could be 8 and 2. It would have to be +8 and -2 to get to the positive 6x. Now that we've factorized it, let's think about what this looks like. It has roots at -8 and 2. and it's a positive quadratic, so it's going to come down and come up through 2 and minus 8. The y-intercept, we know from the original form, is minus 16. As with the last one, we could also have completed the square. X plus 3 squared, half of 6 is 3. We'd have to take away the 9 and then take away the 16, which means in total we would have minus 25, which means that our vertex would be at minus 3, minus 25. With these ones, if they don't specify which points to label, you can use either factorized form or completed square form. Normally in a question they would specify, maybe they want both, but depending on the situation, one might be preferable to the other.